Good morning students, this is the last topic from the chapter 7 alternating current. Now the topic which you are going to discuss today is your LC oscillations. Now already you know L stands for inductance and C stands for capacitor, or you can say L stands for inductor and C stands for capacitor. Now let me to read out what we have written here. Electrical oscillations produced by the exchange of energy between a capacitor which stores electrical energy and an inductor which stores magnetic energy are called LC oscillations. So oscillations, you see, exchange of energy will occur, electric energy and magnetic energy, and one component responsible for electric energy and another component responsible for magnetic energy. Now let me continue the next para. An electrical circuit containing an inductor of inductance L and a capacitor of capacity C connected in parallel is called as tank circuit. So this is known as tank circuit. This circuit gives rise to oscillation is called LC oscillations. Now you see how the oscillation occur. Let me to explain. Now you do have a capacitor and you do have an inductor. Now let me consider the capacitor is fully charged. Now when the capacitor is fully charged, it means it has maximum amount of energy, and that energy can be given by this equation U equal to CV square by 2. Now what happened when the capacitor is fully charged? It starts discharging with respect to time. Now as it starts discharging, it means the energy stored in the capacitor decreases by this equation U equal to CV square by 2. Now when the capacitor starts discharging, current starts flowing, and as a result the energy across inductor increases by this equation half L I square. Now when the capacitor is fully charged, it starts discharging, and that discharging produces current, and that current increases the magnetic energy stored in the inductor but simultaneously decrease the energy stored in the capacitor. Now when the capacitor is discharged fully, then electric energy is 0 and the magnetic energy is maximum across the inductor. Now what happened? When the magnetic energy is maximum, it starts charging the capacitor again. Now this magnetic energy helps to charging the capacitor. Now as a result, the energy stored in the capacitor increases, and when the magnetic energy goes to minimum, then again the electric energy across the capacitor again increases. Now this way the energy keeps on moving from capacitor to inductor and then from inductor to capacitor. Now let me go for the mathematical part. Now already we know Q by C is for potential across the capacitor, and the EMF across the inductor is your minus L di dt. So if we take the di dt one side, then Q by minus LC, our Q by LC minus you will get, then I equal to dq dt, so you will get d square Q dt square minus Q by LC. So let me take out or take the terms in one side, then you will get d square Q dt square plus Q by LC. So it is an equation of Q, and this equation has similarity with the simple harmonic motion, d square x dt square plus omega square x. So if you compare, then omega square is nothing but 1 by LC. So omega equal to 1 by root LC, and omega is 2 pi nu equal to 1 by 2 pi root over LC. And this is the natural frequency of charge which varies sinusoidally, as this equation has a variable charge. So this is one important parameter of LC oscillation, and here the exchange of energy occur electric energy, then magnetic energy, and from magnetic energy to electric energy. When the capacitor is fully charged, it starts discharging, and as a result current starts flowing. So energy stored in the capacitor decreases, whereas the energy stored in the inductor increases. Now when the capacitor has zero energy, then magnetic energy is maximum. Now when the magnetic energy is maximum, again the capacitor starts charging at the cost of the energy stored in the inductor. So simultaneously the charge is maximum again in capacitor, so again energy is maximum and the energy is minimum in inductor. So in this way the flow will continue with the frequency nu equal to 1 by 2 pi root LC. Now these equations are used for electric energy and magnetic energy. In case of inductor it is magnetic energy, in case of capacitor it is your electrical energy. Now let me go for a few numerical. Number one numerical, the equation of an alternating current is I equal to 20 sine 300 pi t. Calculate the frequency and RMS value of current. So already we know I equal to I naught sine omega t in case of a resistor when an AC source is connected. So if you compare this equation with the given equation, then it's your I naught is your 20 and omega is your 300 pi. So 2 pi nu 300 pi, so nu equal to 150 hertz, and obviously I naught equal to 20 ampere, and IRMS equal to, already we have defined the equation, IRMS equal to I naught by root 2, so it's here 20 by root 2, so 10 root 2. Next one, write the general equation for the instantaneous EMF of 50 hertz generator whose peak voltage is 270 volt. So again E equal to inner sine omega t, that's your EMF equation. Now here instantaneous EMF of 50 hertz generator, that is your given is your whose peak voltage is your E naught 270 volt and frequency is your 50 hertz. So instantaneous EMF is your E naught sine omega t, so 270 sine of 2 pi 550 t, so you will get 270 sine of 100 pi t. So these are the numericals related with the topic. So please go through the similar numericals and try to go through this chapter. In the coming class we are going to start a new chapter, that is chapter 8. This is your chapter 7. Chapter 8 we are going to start. So please go through. Thank you.